Previously I made a video on the interface of the Coppercube 3D game engine editor. I am now going to try to make a game with the engine. We will see how far we will get within this video. I am going to make the game as a web application. I am trying to find my way around this. What I do is not necessarily the best way to do it. It is a part of my journey to get to know this editor engine. I start with setting the screen size to 640 pixels by 480 pixels, which is my preferred screen size. Now, since this is a browser game, and most, maybe all browsers today require an action from the user before playing sound, I like to have a first scene with the sole job of being clicked on to move on to the next scene. That will be a menu screen. So I set up one scene and name it Click Room, and a second and name it Menu Room. I can remove the mesh and skybox that comes with the scene. We do not need them for the Click Room scene. For Click, I add a 2D overlay item. This works pretty much as an asset in a 2D game. It is placed on the screen, not in the 3D world of the game. So we change the position mode to absolute and set X and Y to 0, 0, which is top left corner, and width and height to 640 and 480, which is the screen size. The display will now cover the complete screen. I'm not going to use a draw a background. Instead, we add an image. I have an image that I use for this purpose in 2D games. It will work here too. So I add that, and we can now check if this is working by using a test as WebGL HTML, and we can see that the screen opens up in your main browser. So far, so good. I make a new scene which will be the menu screen. I do the same things as for the click scene. For the image, I at this time only pick a texture from the texture list as a placeholder. Going back to the click scene, I add a behavior to the overlay. When clicked on, do something. I add an action, switch to another scene, and I pick the menu room scene as the scene we are going to change to. So now we can test this. And that works as well. So our game does something. Well, not much, but at least something. We are on the way. There is one thing I am a little bit concerned with. The menu screen will typically have buttons with click functions. So I am a bit concerned that a click on the click screen will carry over to the menu function if the mouse happens to be on top of such a button. The workings of a mouse button or a keyboard key can be seen as having 4 different states: up, on press, down, and on release. So let's see what we have here. I add an additional scene. In this I build and add a building using the function room. See the previous video if you don't know how. I also add a click on something behavior to the overlay in the menu scene. So let's see what happens when we click on the click scene. When we try this out, I can find that when we click on the click scene, we go to the menu scene, and we need an additional click to go to the house scene. So my fear that the click could move through from the click scene to the menu scene and then to the house scene showed to be unfounded. Looking at when the shift to the next scene happens, we can see that the reaction comes at on release. So now we know that. We have another way of detecting mouse clicks from the behavior when a key is pressed, which includes mouse clicks. We have two options, press down, respective left up. Testing these options the same way, we will find that press down is on press and left up is on release. So there we have some more information. It also gives us a base to find down and up of a key. We will get back to that later. First, we add a first-person shooter camera to the scene. We automatically get a first-person shooter behavior and collide when moved. That will make it possible to walk around in the room and make observations. So we use the mouse to point the direction forward, arrow up, move the camera forward, arrow down, we back away, and arrows left and right to crab walk left or right, still facing forward. So this is a method to move fitting for a fighting game. You are moving facing a possible enemy, ready to fire at them using a mouse click. A strange thing is that if I mouse click, the cursor disappears and I need to click escape to get back. That goes away if I uncheck use pointer lock for first-person shooter cameras. Seems a bit unintuitive to me. I might have to get back to look more at this question. We can now move in a scene. What I want to do next is to set up an overlay that we can write to get feedback from the game, to check if the code is generating the output we want. It is sort of a debugging window. So first we create an overlay and place it at the top left corner. We set this one to contain text and set it up for multi-lines. Okay, so under house scene we are setting up a behavior before first drawing do something. We set an action for this, execute JavaScript. So now we have a JavaScript that is starting to run, the first thing that is happening in this scene. We're going to set up a function, call it onFrame. We are going to use a bit of Coppercube code, CCB register onFrame event. And we will set that as onFrame, that is our function. So now this function will run every frame for the whole of the scene. Now we want this code to add text to our overlay. First thing we can do is to check for the position of our first-person camera. We will create a JavaScript variable node, and we're using Coppercube code. CCB get scene node from name. The name of our first-person camera is camera1. We will also create a JavaScript variable called overlay and get that from our display. In the function, we get the position of the first player camera in the JavaScript variable called pos. We use CCB get scene node property. We have the name of the camera, the JavaScript name, node, and we get position. From position we can get the values for x, y, and z. We will make JavaScript variables for each of them. We will use mathfloor to remove all decimals. Having the whole numbers will be fine. Var pos x equals mathfloor pos point x, and so on for y and z. We will then have a JavaScript variable text, which will read pos colon and a empty space, and then we add pos x, we add a colon, and we add pos y, and we add a colon, and we add pos z. We then write this text to the overlay using CCV set scene node property. Overlay, that is the JavaScript name of the node. Text is what type of thing we are going to add, and text here is the JavaScript text. So now we can have overlay doing something. Let's see how that works. Okay, now let's make a way to read if the left mouse button is down or up. I start with making two key pressed events, both for the left mouse button. One for button press down, which we know is on press, and one for left up, which we know is on release. In both cases we set a value to a Coppercube variable we call VMB, value 1 for press down and value 0 on release. This means that the variable VMB will be 1 when pressed down and change to 0 on release, and it will stay 0 until on press. So we then want to add this information to our display window. Before the function, I add a JavaScript variable holding a string that will be up or down. This string will be shown in the display. Inside the function we get the value from the Coppercube variable, 1 or 2, and set the JavaScript variable to that value. And using that we set the string variable to up or down. And finally we add the string to the text string. I also add \n to put the up-down information on a new line. We do a test run, and we can now see on the display if the left button is up or down. So this gives a bit of information on how this display can be used to check out what happens behind the scenes, so to speak. Now, when programming, we know that code is very sensitive to typos and such. One little mistake in your code might not work, and it might not be that easy to spot the mistake. So you want an editor that helps you spot mistakes. Coppercube's JavaScript window does not give that to you. You are on your own. But you can use a separate editor that gives you that kind of help. Write your code there and then copy it to the Coppercube window. That will help you with the JavaScript, but not with the Coppercube code. Another option is that your favorite browser probably comes with options for developers' tools, and you can use that to check for bugs in the program. I am using the DuckDuckGo browser, and it does have a developer's tool that can be used to find some errors. So, with these possibilities, I feel fairly well armed to make JavaScript code in Coppercube and have some debugging possibilities. Well,
I guess this will have to be enough for this video. Thanks a lot if you are still around to the end of this video. See you later. Bye.